Now let's test the registration API. So this is our URL and we need to send a post request and we are going to send JSON as the request body and we are passing the user's information. So let's head this URL and the API is working absolutely fine. We got the information, this user is registered, and we also got the authentication token that we can use to authenticate other APIs that requires authentication. Hi everyone, my name is Bilal Khan and you are watching Simplified Coding. Welcome to another brand new course at Simplified Coding, and in this video we are going to build a RESTful API using our favorite language, that is Kotlin. So in this video, I will be using Ktor framework to build a complete RESTful API using Kotlin language. So I hope you all are excited, and now let's start our project. First, we will install all the tools required for this project. So the first thing that we need is our IDE where we will code the Ktor project. And you can use any IDE, but for this example or this course, I am going to use IntelliJ IDEA. So on internet, search IntelliJ IDEA and you can download the community edition that is absolutely free. So I have already downloaded and installed this tool, so I do not need to do it again. But in your case, you can install it if you do not already have this tool. Now after this, we are going to use PostgreSQL for the database. So you need to search PostgreSQL and you need to install this tool as well. We are going to use this as our database. With Ktor, you have a number of SQL and NoSQL options for the database. But in this example or for this example, I am going to use PostgreSQL. I have already installed PostgreSQL as well, so I will not do it again, but in your case, you need to do it. So we are going to use IntelliJ IDEA and PostgreSQL. So first, you need to install these two things. So you can pause this video, install these two things, and you can come back. Now let's move ahead. Now the question is how to create a Ktor project. And to create a Ktor project, you can search Ktor project generator. And you can open this URL. And from here, you can create a Ktor project. Here, I will name my project as My Story App. Or you can name it whatever you want. Now here you can set the package name and I will change the website and I will change it to my website, that is simplifiedcoding.net, and this is the artifact. Now everything else is fine and we will click this button, that is add plugins, and from here you can add all the plugins that you need for your project. But for this example, I will not add anything and I will just generate the project. Now you can see here we have our project generated. You need to unzip this folder and you need to open this folder in IntelliJ IDEA. Here you can see I have opened the project in IntelliJ IDEA IDE and here you can see the project directory. Now we need to open this source folder and here we can write our main code, and in this test we can write test cases. So by default you get this application.kt and you get this routing.kt. Inside application.kt you can see we have a main function, and inside the main function we have an embedded server, and this server will run at port 8080 and the host is 0000. You can change the IP if you want. Let's say I want to make it 127001. Now inside this embedded server, we are calling a function that is configure routing. If we go to this function, then we have this function that is an extension of application, and inside the function we have called another function that is routing. It takes a trailing lambda as the parameter, and inside routing we have a get function that is basically a get request, and inside get we are responding with hello world. And the same way you can define other routes for your application. Now if you run this application now, you will see hello world. So let's run and check. So here you can see our application is running at 127.0.0.1 and the port is 8080. If you will click here, it will open the browser and here you can see we are getting hello world. So what happening is we are requesting this root, that is our root URL, and from here we are getting hello world as the response. So we have successfully created a hello world application in Ktor. But for this example, I am going to build a story application. And the first thing that we will do is we will create a user authentication system. That means the user can log in and the user can register. And this basically means we will store the user information in our database. So next, we will learn how to configure database for our Ktor project. Now before configuring the database, we need to create a database. And to do this, we will open terminal. And here, I will write the command that is PSQL hyphen capital U and then my username, that is Bilal Khan. Now I am inside Postgres and here I will run the command that is create database my story app, like this, or I can write it in caps like this, and you can see the database is created. Now we can use this database for our application. And now we can configure this database in our Ktor project. Now we are inside our Ktor project. And one thing I just forget, we need to add some dependencies for our project. And after that, we will start configuring the database. So what we will do is, we will go inside this build.gradle.kts and here we will add all the dependencies that is needed for this project. So here I will paste all the dependencies that are required. Now apart from these two dependencies that are available by default, we added Jackson for serialization and deserialization of JSON data. Now we also added Ktor auth and Ktor auth JWT because we are going to use JWT, that is JSON Web Tokens, for user authentication. And I think I don't need this one, so I will delete it. Then we have expose library that we will use to create databases in our database. And then we also have library for PostgreSQL. And finally, we have Hikari CP for creating a JDBC database connection pool. So we need all these dependencies for our project. You need to add all these dependencies and then you can click here to sync your project with all the added dependencies. Once all the dependencies are added, we can initiate the database configuration. Now to configure database in our main package, we will create one more package and I will name it DB, that is database. Now inside this package, I will create a new Kotlin class file and I will name it database factory. Or you can name it whatever you want. I am going to create an object here. Now inside this object, first I will create a function and I will name it init. and this will initialize our database connection. Now to connect with the database, what we will do is we will write database and we need to use this class that is from exposed library. So we will write database dot connect. Now inside this connect function, we will pass a Hikari database source. So we will create one more function at the bottom and we will write private fun Hikari and it will return a Hikari data source like this. Now here first we will create a Hikari config. So we will write val config equals to Hikari config like this. Now we will set some configuration to this Hikari config. So here you can see we have added the configuration, we have added the driver class name, the JDBC URL, and here inside this URL, this is the database name and this is the user's name. And finally, after setting all the values, we will return a Hikari data source with this configuration that we defined here. Now here, inside this connect function, we can call Hikari to get the Hikari data source, like this. Now to initialize the database, we can go inside application class and we can call database factory.init and it will initialize the database. So let's run the application and see whether it is working or not. Now here you can see we are getting some error while building the application. So the problem is I just forget to change the version. So when we generated the project from Ktor starter, we got this latest beta version. So we will not be using it, but we will use the stable version that is 1.6.8. So make sure you are using this version. Now we need to rebuild the project and now we are getting some errors. So what we will do is we will delete all the imports and we will import them again like this and respond text as well. Now everything else is fine. Let's go to application.kt and here also everything is fine. Now let's build the application again. Now again, we are getting an error that says my story app does not exist. And the problem is we need to write the database name in small case. So what we'll do is we will change this my story app to my story app with small letters like this. Now we will run it again. Now this time you can see the application is working fine and we do not have any errors. So we have connected to the database. Now let's create a database table. So what I'll do is I will create one more object inside my DB package. So I will select Kotlin file class and I will name it, let's say user table like this. And we will create an object. Now in this example, we are going to use expose for creating database tables. So what I'll do is I will extend table that is from exposed SQL and we will pass the table name here. So I want the table name as users. Now here we will define all the columns that we want for our user table. So I want ID that is an integer and it will be auto increment. Then I want full name. It will be a varchar. We will pass the column name and the length, let's say 256. The same way we will define all the columns. Now finally, we will create ID as primary key. So here I will write override val primary key and I will set the primary key as the ID. Now we have our user table ready, and what we can do is inside our database factory we can create the user schema. So here, after connecting to the database, we will use another function that is called transaction, and inside the trailing lambda we can write schema utils dot create, and we will pass user table that we just created. Now it will create the user table only when the user table do not exist. So we have created the user table. And now let's run the application again to see we do not have any error. And it is working absolutely fine. Now if you try to open the database, I will write PSQL U and my username like this. And then I will select the database, that is my story app, and here I can check select asterisk from users, and you can see we have a table created in our database. So it is working absolutely fine. Now we need to insert users to the database that we just created. And for this, I am going to divide my application in different layers. The first layer will be the service layer that will actually interact with the database. So what I will do is inside my main package, I will create one more package and I will name it service. Inside this package, I will create an interface and I will name it user service. Inside this interface, I will define all the functions, or I will declare all the functions that are required to access the users table. For now, I will just define two functions. The first one is suspend fun register user, and to register the user we can pass the parameters that are required to register a user. So we need to create one more class here, create user params, and it will return a user. Now here we need to create two classes. One is the model class for the user. So I will create one more package and I will name it models, and inside this I will create a class user. Now this will be our data class, and for the attributes I will define all the fields that I have for my user table. Now apart from all the columns that we have in the user table, we defined one more string for our data class user, and this is the authentication token. And whenever we will log in a user in our application, we will generate an authentication token to authenticate the user, and that is why I have defined one more field here. Now we need to define one more data class, that is create user params. So we can define it inside service only. So let's create a new Kotlin file class and name it create user params, and it is a data class. Now whenever we will register a user, we will pass name. So let's say we have full name of type string. We will pass email, that is also string, and we will pass password, that is also a string. And if you want a profile picture for your user, you can also pass avatar, it is also a string. Now I have create user params, and now we can use this params in our register user function. And whenever we will register the user, it will return the registered user. If any error occurred and the user is not registered, we can return null. And that is why I have made this user as nullable. Now I will define one more function here, And this function is to find user by email. So I will define one more, that is find user by email, like this. And to this function we will pass email, that is an string, and this function will also return a nullable user. Now I defined this function because whenever we will call this register user function, first we will check if the given email already exists or not. And that is why I have defined this function here. Now we will create an implementation of this interface. So I will create user service impl, and inside this implementation we will actually register the user in our database. Now to insert the given user or to create a new user in the database, we need to run query. And to run a DB query, I will create a function inside my database factory. And here I can create a suspend fun, and I will create a generic function. So I defined type as T, then I will name it DB query and it will return T, and here I can use with context, and we can use dispatchers IO to run the DB query. And inside the trailing lambda, I can use the function transaction to perform the query. And we can pass the query to this DB query function. So this function DB query will accept another function that will be our query. So I will name it block and it will return T. Now here inside transaction, I can call this block like this. And now we can use the DB query to perform the database queries. Now let's go back to user service IMPL. Now here I will create a var that is of type insert statement. So we have insert statement and the initial value will be null. Now I will write DB query like this. We need to import this. So we have DB query. Inside the DB query, we will write statement equals to, and we will call user table dot insert, and we will pass it email equals to params dot email, and the same way we will pass all the values. For password, we need to encrypt it. So I will write a to do here that we need to encrypt the password, but we will do it later. For now we are saving the plain password. The same way I will write full name equals to params dot full name and then avatar. Now this way we can insert a new user in our user table, but we also need to return the inserted user, and to get the inserted user we will define one more function, and this function is private fun row to user, and this function will take row, that is result row, and it will return user. Now we will return if row equals to null. In that case we will return null, else we can create the user from the row that we have here. So I will create a user and I will pass all the values. So we have row user table dot id, and then we have full name, and the same way we will pass all the values. Right now we do not have the authentication token for the user. So what I will do is I will add names, and instead of this auth token I will write created at, because we have a default value for authentication token that is null. It is not necessary to pass the authentication token. So we will learn how to generate authentication token later. For now, this function will give us the user. Now here inside our register user function, we will return row to user, and we will pass the row that we got from this statement. So here we will write statement dot resulted values dot get, and we will get the first value like this. Now this function will return the user that is inserted. Now let's define implementation for this function as well. Here we will write user equals to db query, and here we will write a select query, that is user table dot select, and then again we will write user table dot email, and we will use the function eq, that means equals to. So we need to find the user with this given email. So here we will write user table dot email equals to, and we will pass the email. Then finally we will call the map function, and we will map it row to user. And we can write here single or null. Now it will return user if it already exists, or it will return null. And finally we can return the user here like this. Now we have implemented both functions, register user and find user by email. Now I will create one more layer that we call repository, and repository will call the functions from service. So I will define one more package here, and I can name it repository. Inside repository, I will create one more interface, and I will name it user repository like this. And here also I will define two functions. The first one is register user, that will take params, that is create user params, and we need to create an interface. So I will delete class and I will write interface, and I will define one more function that is for user login. So when the user will log in, he will pass email and password. So we have email and password here like this. So we have the user repository interface ready. The same way, we will implement this interface, and we will write the implementations of these functions. But first, we need to define the return type of these functions, because we will call these functions from roots. We need a response type as the return type of these functions. That means whatever we will define as the return type, we will get it as the JSON output. So we need to take care of all the cases. For example, when we try to register a user, it may happen that the user is not registered. So in that case, we need to return some error response. So to structure our responses, we can use sealed classes. So I will create one more package, and let's name it utils. Inside utils, I can create a base response. Now it will be a sealed class, and to the constructor of this class, we can pass status code, that is HTTP status code, and the default value will be HTTP status code dot OK. Now inside this base response, I will define two data classes. The first one is success response, and because we are going to use it everywhere, we will define the type as T. Now again, we will use T here for success response, and we will define two values for success response. The first one is data that we will get, and in case of failure, it will be null. And we will get message, and we can make it null as well. Now we will extend base response like this, and the same way we will define error response. So we have the response class ready. Now to our repository, we will write here base response of type any. And the same way, we will write base response of type any. So we have two functions ready. Now let's write the implementation of this interface. Now here, first we will check if the given user already exists or not. So we need to define a function here. So here we will write private suspend fun and we can name it is email exist, and it will return boolean whether it exists or not. And from here we can return true or false. And to check the user exists or not, we can use the service that we already created. And to use the service, we need to pass it here. So to the constructor of our user repository implementation, we will pass the service interface. So we will write here user service. Oops, I forget to write val. So it is private val user service. Now here I can write user service dot find user by email. We can pass email and we can return it is not null. And we need to provide email here. So we have email of type string. Now here in our register user, we can check if user exists. So here I will write if email exists and we will pass the emails from params. If it already exists, we will return the error response. And we can pass the message as email already exist or registered. Now we can write return here. That means it will return error response if email exists. In case of else, we will register the user and we will return the success response. So first we will get the user by registering it. So we will write val user equals to user service dot register user and we will pass the params. Now we will check if the user is not null, that means user is successfully registered. So what we will do is we will write success response and we will pass the data as user like this. And we will write else, and in case of else we can return error response like this. Now our register user is ready. We just need one to do, that is when the user is successfully registered, we need to generate an authentication token, and we will do it using JWT. But later. First, let's test this user repository. And to test the user repository, what we'll do is we will define roots. And you can see we have a package named plugins. So what I'll do is I will delete this package and I will define one more package and I will name it roots. Now inside roots, I will define a Kotlin file and I will name it auth, or you can name it whatever you want. Now I will create an extension function of application and the function name can be auth roots. Now to this function we need to pass the repository because from the repository we can register the user. Now I will define a routing group, so I will use routing and inside routing I will define route and I will define auth, it is the prefix, and inside this auth I will define a post and the path would be register like this. So this is how you define roots in Ktor. So the root is the base URL, then /auth and then /register. So whatever I will define inside this auth root will have the prefix /auth. Now inside register, what I will do is I will get the request body from the request. And to get the params, we can use call.receive. And to this function receive, we need to pass the type that we want to receive. In this case, it is create user params. Now we have params, and with the help of params, we can register the user. So we can call val result equals to repository dot register user, and we can pass the params. And finally, we can send the response using call.respond, and we can pass the result like this. And we can also pass the status code from the result. Now we can call this register URL to register the user. But first, we need to register the auth roots. And this we will do inside application.kt. So we deleted this function, so let's delete it. So inside our embedded server, first we are initializing the database factory, and then we also need to install content negotiation, because we are accepting this content from the call, and to do all these things we need to install content negotiation. And inside content negotiation, we also need to define what we will use for JSON serialization and deserialization. For this project, I am going to use Jackson, and I have already added Jackson in the dependencies, so I have installed Jackson. Now finally, I will call auth roots, and to the auth roots, we need to pass user repository. So first, I will define user repository equals to user repository IMPL, and to define the user repository, we need the user service. So I will write here service. So we have the service, and with the help of service, we can define the repository, and with the help of user repository, we can call this auth roots. So we will pass the repository here. For now, we are not using any dependency injection, but later we will also use dependency injection. So for now, our auth roots are ready, and we can run the application to test it. So let's run it. You can see it is working fine. So let's hit our auth URL. So here you can see this is our URL where we will send a post request with this JSON request body. So let's send the request, and you can see our application is working fine. The user is registered. Now if I try to send the request again, I will get email already registered. So it is working absolutely fine. Now let's also check the database. So if I run the query now, I will get values inserted in my database, as you can see here. But you can see we are saving the password as plain text. That should not happen. So let's encrypt the password. And to encrypt the password, I will create one more package, and I will name it security. And inside this package, I will create one more Kotlin file, and let's name it password encryptor, or you can name it whatever you want. Now inside this file, I will define a function that will hash the given password, and it will return the hashed string. Now I need secret key, and for secret key I will just use random number string. I also need an algorithm that I will use for hashing the password. Now we need to create a hash key, and I will use the function hex and I will pass secret key to create our hash key. Now I will define one more, the algorithm key, and for this I can use secret key spec and I will pass the hash key and the algorithm like this. I can make all these values private. Now inside this function, we will hash the given password. So first I will create a val and I will get the instance of Mac, that is from javax.crypto. So I will call get instance and I will pass the algorithm. Now we will initialize this Mac, hmac. So we will call init and we will pass the hmac key. Now finally we will return hex and we will use hmac.doFinal, and to this function we will pass the password as byte array and we will use the char set of UTF-8. Now this function will hash the password, and to test this function we can use a scratch file. So double press the shift key and write scratch and select Kotlin, and here we will select the main module of the application and make sure you mark this option, that is make module before run. So here I will define a password. Let's say the password is 1234 and then I will get the hashed password using this function hash, and now we can print this hashed password. Now we can play this and we'll see whether it is working or not. So you can see the password is hashed and now we have the encrypted password that we will save to our database. So let's go to the repository. We can hash the password at the repository layer as well, but we can also do it at service layer. So go to register user and here we can hash the password. So here we have added a to do. So what I will do here is I will write hashed and password. Now if I run the application again and if I hit the same URL, let's change the email to 11. You can see the user is registered, and if I run the query again, you can see this time the saved password is hashed. So it is working absolutely fine. Now one more thing we need to do is we need to authenticate the user using authentication token. And for this, we are going to use JWT. So inside the security, what we will do is we will create one more Kotlin file class and we will name it JWT config. Now inside this file, we will define a class that is JWT config, and I will make the constructor private. Now it will take a secret string, and for this we can use any random string, and I will define a private val algorithm and it will be algorithm HMAC256 and we will pass the secret. Now we also need to define a verifier and it is JWT verifier. So we will write JWT dot require the algorithm, then we will use with issuer and with audience, and then finally we will build this verifier. Now for issuer and audience, we can define a constant. So I will create a companion object and I will define private const val issuer equals to, let's say, my story app, and the same for audience. And I can also define a claim that we will use to authenticate the user, and for claim we will use ID. So let's pass issuer and audience here. Now we will define a function that will generate the access token for the user. So here I will write create access token and it will take the ID of the user, that is an int, and it will return a string, that is the access token. So here I will write JWT.create again with issuer and with audience and then with claim. For claim, we will pass the claim that we just defined here, and we can pass the ID that we want to claim, and then finally we will call the sign function to create the access token. And for sign function, we need to pass the algorithm. Now we can use this function to generate an access token for our user. But first, we need to define one more function that will initialize this JWT config because the constructor is private. So here we will write fun initialize inside the companion object so that we can call it from anywhere. Now I can use synchronized block, and here I will check if the instance is not initialized, we will initialize the JWT config. And for this, we need to define a latent var instance that is of type JWT config, and I will make the setter as private because I just want to access this instance, but I do not want to set this instance from outside this class. So here we will check if this instance is initialized, and I have added a not here. That means if it is not initialized, what we will do is we will initialize it. So we will write JWT config and we will pass the secret like this. And now we can call this function to initialize the JWT config. Now we will use this JWT config to configure JWT. And for this, I will create one more Kotlin file class and I will name it configure security. Inside this file, I will create an extension of application and I will name it configure security, and inside this extension function, I will call install and I will install the authentication. And for authentication, we will use JWT. For verifier, we will use JWT config dot instance dot verifier. And before doing this, we can also initialize JWT. So here we can write JWT config dot initialize and we can pass the secret. Let's say my story app. Now here we can use the instance, and from the instance we can get the verifier. Now finally we will call the function validate, and here we will get the claim. So for claim we can get the payload, and from payload we will get the claim, and we have JWT config dot claim, and we will get the claim as int because for our user we have the ID as primary key, that is of type int. Now here we will check if claim is not equals to null. That means we will validate the user using the claim, else we can pass null. Now to validate the user, we need to create a principal, and we can create a new class that is user ID principal for user like this, and we can make it a data class, and for this class we can pass the id that is of type int, and it will extend principal from Ktor auth. Now let's go back to configure security, and here when the claim is not null, we can use user id principal for user, and we can pass the claim like this. Now we need to call this configure security inside our application. So here inside this embedded server, we will call configure security. So we have called configure security, we have called auth routes. And now we can generate the access token for the user. So let's go back to user repository IMPL, and here we will call JWT config dot instance dot create access token, and we can pass the user's ID like this. So we will get the token here, and we have the token. Now before returning the user, we can write user dot auth token equals to token like this. Now let's run the application again and see whether it is working or not. So if I register one more user, you can see I am getting the authentication token. Now we can use this token to authenticate other URLs that requires authentication. For example, I can show you a sample URL. Just for example, I will define one more routing here. You should define it inside other files, but just for example, I am defining it here. So let's say we have routing, and for all the URLs that you want to be authenticated using an authentication token, you can write them inside this function, that is authenticate. Now inside authenticate, if I define a get, let's say I have a get test URL, and I will write call.respond working fine, just for the example. Now if I run the application again, it is working fine. Now let's open Postman, and first we will hit the register URL, and from here we will get the token. Now copy this token, and in a new tab we will hit the test URL that requires authentication. So if I hit a get request now, I will get 401, that is unauthorized error. But what if I send an authorization on the headers? So I will send bearer and then the token that I just copied. I am still getting unauthorized error. So I think we have some issues. So let's check. And here you can see in the logs, I am getting token verification failed. The claim value doesn't match the required issuer. So I think we did some issues here. And yeah, you can see here I have called with audience 2 times. But first I need to call with issuer here like this. So now I will stop the application and run it again. Let's go back to Postman again, and this time let's say 313, and I will register a new user. We have the token, and now if I hit this URL, I am getting 401 unauthorized, and let's pass the authorization header. So I am passing bearer token. Now if I send the request, you can see it is working. I am getting 200. So it is working absolutely fine. So that is all for this video, friends. I hope you found this video helpful and learned something. In case you have any problem or confusion or question, you can leave it in the comments below. And in the description, you will get the link to the source code. and in the source code I have added all the other endpoints that are required for this project. And in the next video we will consume these APIs and we will build a complete Android application, and this time we will use Jetpack Compose to build the Android application. So I hope you all are excited. And finally, please hit on that like button, subscribe to Simplified Coding if you're not already a subscriber, and share this video with all your friends who are learning Android application development. So thanks for watching everyone. This is Bilal Khan now signing off.